Hello students, let us discuss under the chapter Electrochemistry how to calculate the value of Gibbs energy for an electrochemical cell like a Daniell cell. Now, electrical work done in 1 second is equals to electrical potential into total charge passed through the cell. Now, the maximum work is obtained if the charge is passed reversibly, then the reversible work done by a galvanic cell is equal to decrease in its Gibbs energy. That means in a cell, the process, if it is in reversible process, the cell reaction occurring reversibly, then the reversible work done, that is, can be calculated as the change in Gibbs free energy is equals to the charge passed, that is number of electron change, into F, that is the Faraday, into E cell, that is the cell potential. Now, for the reaction that is taking place in the galvanic cell, like this, Zn reacting with copper 2 plus, giving Zn2 plus copper. This is the cell reaction of Daniell cell. We will find that the Gibbs energy is equals to minus NF E cell. E cell is the cell potential that can be calculated by using the Nernst equation. So for this reaction, if we apply the Nernst equation, it is E cell equals to E0 cell minus 2.303 RT by NF log of Zn2 plus this concentration divided by the copper 2 plus concentration, and since copper and zinc being solid, their concentrations are taken as unity. Now, at the standard state, that means when the galvanic cell is in the standard state, that means the concentration of the electrolyte Zn2 plus and the copper 2 plus in the two half cells are having 1 molar concentration. In that case, what is happening? These two values are 1, so it is log 1 is 0. In that case, E cell equals to E0 cell. And therefore, we can get the Gibbs energy as the Gibbs energy in the standard state for this cell reaction is equals to minus NF into E0 cell. Here, E cell is becoming E0 cell. Now we know that from thermodynamics, the relation of Gibbs energy is equals to the Gibbs energy at the standard state plus RT ln QC. QC means reaction quotient. That means when this reaction is not at equilibrium, and when it is in equilibrium, then this Gibbs free energy change is becoming 0. Therefore, this equation changes to delta G0, that is standard Gibbs free energy, is equals to minus RT ln. Instead of QC, now we can write K equilibrium, as because we are considering the equilibrium state. So this relation is becoming delta G0 is equals to, if we write this ln into log with base 10, 2.303 RT log K equilibrium. So from this relation we can have, if we want to calculate the Gibbs free energy from equilibrium constant, knowing the value of equilibrium constant, we can get this one, and vice versa. Now another relation that we can get here, that from this equation 2 and from this equation 3, we can write that NF E0 cell is equals to 2.303 RT log K equilibrium, and therefrom E0 cell is equals to 2.303 RT log K equilibrium by NF, and therefrom E0 cell equals to, if we apply the R value, is equals to 8.314 joule per Kelvin per mole, T equals to 298 Kelvin, and F equals to 1 Faraday, that is 96487 Coulomb. The result is becoming E cell equals to 0.059 by N. N is the number of electron change taking place in the reaction into log K equilibrium. So these relations, from these relations we can get, there are three values: Gibbs free energy, equilibrium constant, and the cell potential. So numericals based on these relations are given in exams, and we can calculate those things by using these relations. Thank you.